Hello, my friends of Hateri Labs. My name is Sol Montoya. Please have a great day. In this tutorial, we are going to do an unstructured grid groundwater flow model with MODFLOW 6 and Model Muse 4. Okay, MODFLOW 6 is the latest version of MODFLOW that allows triangular discretization and unstructured grid. And okay, so you can know more about MODFLOW 6 on this link. Okay. You can also download MODFLOW 6 here. And Model Muse is already in version 4. And for the people that that follow our channel, this release is from some days ago. So the latest release is of June 21, and okay, and you can download it here from the installer, for example. And this version allows an unstructured grid. Okay, so what we are going to do here is we are going to make an example about how to do unstructured grid in MODFLOW 6 in Model Muse 4 with MODFLOW 6. Okay, let's start. Okay, first start by opening Model Muse. I have already downloaded and installed. We are going to create a new MODFLOW model. Let's type a projection here. This is just declarative. Next, we are going to have a three-layer. We are going to have a three-layer aquifer, but the top of the bottom elevation of the inferior layer is minus 120. And that's it. We are going by the no grid options. Okay. Okay. This is the usual user interface of Model Muse, so nothing has changed here. But actually, we are not going to work with this normal interface, but we are going to go um, to grid and switch to unstructured grid. Okay, with this you switch to another interface that is the one that allows unstructured grid, and is different. Okay, this is the other interface. Okay, so let's start. First, look for the program locations. You need that the MODFLOW 6 is already pointed to the executable. Okay, so you have this stored in your VRD app directory MODFLOW 6, and this is the default. This is the only one that we need for this tutorial. Okay, what else? We go to package programs, MODFLOW package and programs. We are going to work with the MPF and the GNC. On the boundary conditions, we are going to use the well package, the general head package, and the river package. Let's check. Okay. Okay, great. What else? The other thing that you might need is okay, layer groups. Actually, or I have to read more documentation, but it's not possible to define a confine or unconfined. There is also a cell type, but I think that this is related if that is active or inactive. But on somehow if the cell if the head is in between the cell vertical extension, it will be unconfined, and this on the top it will be confined, and this below the bottom cell it will be inactive, as I guess. Okay, so but in this case we are not going to we are going to have either unconfined or confined aquifers. On MODFLOW time we run a steady state. Okay, great. So let's start importing a shapefile. On the description of this video you will have this this structure, and you will have this folder, so you will download it, this one, tutorial of Unstructured grid with the Groundwater model. You download it, and then you will have model, raster, and shape. But actually, you will have I don't like. You will have the. You won't have the depth. Okay. Okay. MODFLOW, raster, and shape. Okay. Let's open the raster folder. Here we are going to open the model limit. Okay. Model limit. And here we set the values of enclosed cell, single multipart object, and nothing more with this. Okay, let's type OK. Nothing has happened because we have to go for the object. Here we go for the object, we press here, and it appears the show or hide object. It's the same as going here, show or hide objects, and here I got the model limit. Okay, double click here. And with this I have the model limit, and this I will set up another color, and I will use to set the grid cell size, and it will be 100 for this model. Okay, what else I do need here? No, I don't need nothing else. Okay, great. So with this I generate the grid. Okay, and this is my grid. Okay, one of the difference between this version or this option of Model Muse is that you don't have the lateral cross section here, rather than you have this line that is the one that specifies the cross section here, and this line you can change of position, and then you can change of direction as well. Okay, it's up to you. I mean, it's more practical because I think that for all Model Muse users, this cross section here was not so helpful. Okay, so it's better to have it here. Okay, we have our grid, but let's do our wells. Let's import our wells. So we go File, Import, Shapefile, and we have a well, we have on set value, and this will place it on the first layer. So on attribute that sets required the definition model top, and here is upper aquifer bottom. Great. Okay, model top, upper aquifer bottom, pop, pop, pop. That's it. Nothing else, and they will import a separate object. Yeah, something that we were looking for. Okay, I won't apply pumping. I have the pumping rates as attribute of the shapefile, but I won't apply it yet. Okay, so these are my wells. Okay, I want to select. Oops, sorry. For example, to this shapefile that is the model limit. Okay, I will do double click. I will do position. It's already position lock. That is great. And then I do right click and then say hide to selected object, because actually I do not need this this polygon. Okay, I mean this polygon is blocking me to select the wells. Okay, so here I have the wells. Okay, and then here I will say on the quad 3 refinement that this will be type 4. Okay, and then I will explain what I have done here. Okay, model wells, quad 3 refinement, layer 4, and then I do OK. Okay, and this, okay, let me do this and then I will explain you what I have done. Okay, I do generate a grid, I do OK, and I have created so easily an structured grid. Okay, and you might think what you have. I mean, there is an okay. I will select again. I will select again the wells, and then I will please. I will select another color to show them. Okay. So far, I haven't done any. I haven't done I haven't select any cell size to do this refinement. So the number 4, okay, because if I will select a cell size to do this, like I will have done that, and then I will have set up this to 10 meters, for example. Okay, but I haven't done that. What I have done is I just do a refinement of 4. And what does mean this refinement of 4? The refinement of 4 means that you have from a cell, it actually go 4 steps. Okay, so this is the first refinement that actually, because by default it refines in, it divides on 4, and then this is the second refinement, this is the third refinement, and this is the fourth refinement. Okay, look what will happen if I type it to 3. If I type here to 3 and then I generate my grid, I only have 3 steps. So this is the cell, first refinement, second refinement, and third refinement. Okay, so that's why we have here 4. Okay, we are going to leave it in 4. Okay, so if your cell was okay, I generate this, and then let's do some calculations. Okay, if your cell was 100, here is 50, here is this cell size is 12. Okay, this is 100, this is 50, no, this is 100, this is 50, this is 25, this is 12.5, and this is, and let's measure, the half of 12.5 is 6.25, something like that, because this is 12.5 and this is 6.3, 6.25. Okay, so it's a good refinement in order to define well. You can type it 5 and it will bring the 6.25 divided by 2 as the cell refinement close to the bone, close to the well. Okay, so far you're doing great. We have our refinement, so let's start importing another features of our model. So let's import file, import shape file. We are going to import the general head boundaries, select of intersect cells. This is a single multipart object, single multipart object. Yeah, can be, no, it has to be separate objects. Okay, great. And this will be 2, and it will go from model top to aquifer bottom. Okay, great. So these are our cells, and there are 4. So let's set up our okay, these 2, yeah, the name is not applied because there are actually two cells. Okay, I mean each one is 1. Okay, but I can select 2 and then make the changes common to the 2 options. Okay, 2. Okay. This is the GHB. -0, and this is 90. And the conductance is direct, and it will be 0.01. Okay, great. That's great. Okay, here we have another, that is these two objects. We change of color always, and then we go here and we do the GHB. Now, GHB from -0 to 1, and this is 55, and this is 0.01. Okay, great. So, yeah. Okay, so we have this define the regional flow. Then we're going to import the river. The river is set value of enclosed cells, single par multi-object, and the river is in one, so it's on the model top. Then we do OK here, and this is our river. I will do double click here and type this one, change of color, and go to MODFLOW features. On MODFLOW features, let's do GHB. No, let's do river, but first let's see what happens if I do quad refinement of 2. Actually, this tutorial do not have this, I'm just experimenting. Okay, look, that's great. I mean, along the path of the river, actually it has divided in 2 levels, 1 and 2. Okay, but somehow let's see what's when it says set value of intersected wells, because it's, I mean, if you have seen here, nothing has happened here because actually it's not enclosed. Okay, here, look. It has done a refinement along the. Okay, I will think that let's keep it this way. Okay, let's keep it this way because it's a great refinement. We have a refinement around the river, and then we have a refinement along the wells. Okay. Okay. Yep. So far it's okay. And then I will set up the river as a boundary condition. Okay. Here I go. Here I go to multiple features. Here I go to river. And the river -1 to 0. The river stage is model top. The conductance is direct, and is 0.01. And the river bottom is model top -1. Okay, great. So this is -1, 0 model top, 001 model top -1. Okay, great. So this is our river. So we have already the boundary conditions, the well, the river, but we need the topography. Let's start the topography. Okay. For this case, we are going to use the topography as points. We are going to upload it as points. Okay. And let's say that this is model top, set values, and let's say by interpolation, and then go to data. Okay, and on the description of this video, you will find here you will find on raster, you will find model them. That is a CSV file that I will open with Excel or LibreOffice is the same. Okay. And then I just select the values. So I just select the values to the end. To the end, to the end, to the end. Control C. I can close it, I can minimize the same. And then Control V. Okay, and this is okay. Yeah, it says that I have selected interpolation and I have not specified interpolation. I will specify later. Okay, great. So if you see here on the, it has already, okay, we have to work little things here. First, let's go to object and let's do hide all objects. Okay, let's go to object and hide all objects. Okay, great. Then we'll go to data, edit data sets. Let's go to model top and define that the define for model top as fitted surface as the interpolation, because we have set this as interpolation. Okay, that's great. Another thing that you might need is that we are going to do a progressive, in between model top and lower aquifer bottom, we are going to have a progressive thickness of the aquifers. That means that the first aquifer will have 15% of the total thickness, and the other will have 35%, and the other will have 50%. Okay, there is a formula for that. I won't go into the definition of the formula, but if you see the formula and then you put sometimes you will get the purpose of the formula. So let's go to upper aquifer, bottom. I will say that this is the lower aquifer plus open model top minus this, and this is 0.85. Okay, this is a formula that actually divides the upper aquifer at 15% of the total thickness. Okay, okay. And this is the 50%, and this is minus 120. So this is 50, this is 8. Yeah. Okay, and okay, we don't see very well on our cross section because our vertical exaggeration is huge. So let's go to view, let's go to vertical exaggeration, and then just type here 4. Even that is huge. Let's type here just 2. Okay, great. So here we have the river. Actually, I will point this. Okay, so I will place okay, so here I have already the initial heads. I have already we have already the boundary conditions, the geometry. Is by default the hydraulic conductivity is 0.01, so it's actually the hydraulic conductivity of sand. Okay, we have the regional flow. Let's do 2 more things. Let's have a review on the solver. Let's go to package and programs. On the solver, we do EMS with big stop. This is for the linear and the non-linear 100 iterations. Relaxation, nothing on relaxation. Okay, let's run our model. Okay, and then let's go to the datasets required hydrology MODFLOW initial heads, and this has to be model top. Okay, so here is case set is 124, the initial is model top, everything is active, and this is the cell type that is, I think, that is active. Okay, let's run our model, let's save our model, and then you will have a copy of the model as well, because it's already on the folder that you will receive. It's on the folder that you will receive. This is a tutorial on the structured grid model, and this will be model 1. Okay, great. So this is model 1. Let's run our model. Okay, as you might see for the discretization that you have, the simulation time is really small. I mean, it's really fast. This simulation has taken only less than 1 second. Okay, and this was like the main. This was like the main support, like the main feature of an structured grid, that actually you can do simulations with less on less time. Okay, it actually optimizes the number of cells and the calculation. Okay, so and our convergence is great. And then if I go here, this is our the river actually brings this amount, so 240 liters, and the general head takes 196, gives 196 and takes some. But as you might think, we have wells here, but actually we have, and it appears on error because we have selected that there are wells, but we have not set any well here. Okay, let's set our well. So let's go here. Let's go to MODFLOW features. So these are the 3 MODFLOW features. But the wells are not as MODFLOW feature because the wells are here. Okay, so here in Part 3 Refinement, model well here, I do double click here, and appears here, these windows appear, where we go to this MODFLOW features option, we click on well, and then we just go from 900 to 0 direct, and this is minus 0.03 because each well is pumping 30 liters per second. And minus because it's pumping and it's not injecting water. Okay, great. So we save our model once again, and then we run our model. Okay, so now, yeah, we have that the river brings this is the general head boundary, and the well is pumping 90 liters per second, the river takes less water, and the GHP takes less water away. Okay, so this is the new arrangement. Okay, one of the great features of Model Muse that is actually you can import your results here. Okay, let's import our results here. So let's go to my results of the Unstructured grid. Let's import it as a contour data. Okay. So, and this is our contour data. And here, okay, this is great. I mean, this is great because we have a refinement, and we it's like having a special scope where actually things happen, okay? Because the main changes of the groundwater flow are related to the boundary conditions. So it's related to certain places where you need more discretization in order to see what is the impact. Okay, if we model this without the refinement, actually the contour lines won't be much affected. But here they are affect. I mean, you won't. For example, you might see this, but you are not able to see this because everything that happens here happens only in one cell. Okay, so maybe this will be average with this, so the control line will be like this. But here you can see everything. I mean, the song of the capture song or the influence song of the wells, and yeah, with great definition, and here as well, and here as well. Okay, and here we see some interactions in between the river. This is where the river is giving water to the system, and this exactly is where the river is uh, draining water from the system. Okay. And what else you can do here? You can do a cross section. Okay, and then with this cross section and this feature, you can see the water table, and actually you see that the first layer is phreatic while the others are confined. Okay. Okay, that is great. So this is the end of the tutorial. I hope that you like this video, and I hope that you like our YouTube channel. You will have a copy of this model for you to run, to play around, and then you also have the input data to do this video, but to do this tutorial by your own. We are Hatray Labs. We are a blog dedicated to knowledge sharing open source software, especially in groundwater modeling. And okay, and this was a great example because Model Muse, this fits the Model Muse, MODFLOW 6 and Model Muse with an Unstructured grid are new, well, relative new features. The purpose and the benefit that you will have by applying these tools are great, especially if we look for the sustainable management of groundwater resources. Once again, my name is Saul Montoya. If you like this video, please follow us, give us a like, and hope to see you in coming tutorials. Bye bye. Bye.